In this video, we'll see how to use GeoGebra to construct the inversion of a point through a circle. First, we'll go down to the input bar and draw a picture of the unit circle. We'll enter the equation of a circle, x squared plus y squared equals 1, and press enter. And furthermore, I don't really need to see these axes, so if I right-click and click on axes, they'll be hidden from view. Next, I want to create a point to serve as the center of the circle. So in the input bar, again, I'll enter parentheses 0, 0, and press enter. That'll give me a center point. Now I don't want the locations of either of these to move accidentally. So if I right-click on an object and go to Object Properties, there's an option for fixing the object. If I click that, it becomes immovable. Similarly, for the center point, I'll right-click, go to Object Properties. I'll also rename the point O for Origin, and click on Fix Object. Now I cannot accidentally click and drag these. Next, I'll create the point to be inverted across the circle. It can be anywhere on the interior of the circle. The inversion of a point A through this circle is another point B, which lies on the ray starting at O and passing through A, so it lies on that ray, but also the distance from O to B will be the reciprocal of the distance from O to A. To construct such a point, first we'll create the line segment from O to A. So I'll choose the segment between 2 points. I'll click the points O and A, and I'll right-click so I can see what the name is. This segment has been named Segment A. I'll keep that in mind. A stores the value of the length of this segment. So I'll right-click and I'll hide it from view. I don't need to see the ray, I just need to know what the numeric length of the segment is. Next, I'll construct the ray starting from the point O and going to the point A. And now I need to find a point B on this ray such that the distance from O to B is the reciprocal of the distance from O to A. Well, the first thing I'll do is I'll construct a circle with a given radius, circle with center and radius. First I choose the center point, I click O, and the radius is going to be 1 over A. And then I'll choose the point of intersection between the two objects, this ray OA and this new circle. Now since B is a point on this new circle, I know that the distance from O to B is 1 divided by the distance from O to A. These distances are reciprocals of each other. And finally, to clean up the picture a little bit, I'll right-click on this circle and hide it from view. Also right-click on this ray and hide it from view. And so now we have a nice construction of a point A and its inversion point B. Furthermore, since A was arbitrary, it didn't depend on anything else in the diagram, you can move around A and see what happens to B. As A moves closer and closer to the boundary of the circle, so does its inversion B. And as it moves closer to the center of the circle, the point B moves further away from the circle. And that is how you construct the inversion of a point.